1 topic number 4, and I think that you guys are going to feel really great about this day because a lot of it should sound familiar to things that you've done in previous years at school. The 4 types of angles that we're going to talk about today are right angles, straight angles, acute angles, and obtuse angles. My guess is that straight angles is the only one that's maybe not completely you're familiar with, but don't worry, we'll talk about it today. So let's just start with a right angle that we is most familiar. So a right angle is an angle that measures exactly 90 degrees. Okay? So if I'm going to draw a picture of this, a 90-degree angle almost looks like the letter L. All right? It's like standing straight up, almost like how a floor and a wall intersect. And so this angle here is 90 degrees, and we're going to use a box to show that that means 90 degrees. So when you have that little box in the corner, that means 90 degrees like that. Okay? And that's a right angle. Now let's go over, I'm actually going to do straight angle last because I think that that's the most complicated. So let's go down to acute angle. An acute angle are angles that measure between 0 degrees and 90 degrees. Okay? So any number between 0 and 90 works, but it can't equal either of those. So an acute angle, let's come up with just a couple of examples. There's no symbol like we have for right angle, so usually you just know the angle measurements. So like 40, right? 40 degrees is between the 0 and 90. Or even as close as 89.9 degrees, right? That's less than 90. That is an acute angle. Moving to obtuse angles. An obtuse angle are angles that measure between 90 degrees and 180 degrees, right? So the right angle is kind of the cutoff between an acute and obtuse. Let's draw a picture of an obtuse angle. So an obtuse angle that looks like this might be like 120 degrees. Or we could have something as small as 91 degrees. That is bigger than 90. That is an obtuse angle. The newest one, or my guess is that it might be the newest one for you, is an angle that measures exactly 180 degrees. The reason why that's kind of a funky one is because that's just a straight line, okay? So whenever you see a picture that looks like this, you know that the measure of this angle from here to here is 180 degrees. Usually how we notate that is we have some points on there, right? So let's say that these points are like A, B, and C, and we'll say that the measure of angle ABC equals 180 degrees. So it's important to know what is a right, acute, obtuse, and straight angle, but a big focus of today's lesson is going to be, can you identify them in a picture, right? So the directions say, use the following diagram to answer the questions below. So we're going to name an acute angle. So remembering from the very first lesson that we did, when I name, that's the notation that I'm going to use. I'm actually going to skip that one because when I'm looking at this picture, I see 3 angles there. I see angle 1, angle 2, and angle 3. And looking at that, none of them give me an actual like measurement, like 40 or 50, like an actual number. I'm looking for a number between 0 and 90, and it's not there. So I actually want to start with something that is in the picture that's marked. I see that box, and we just went over that that box means that it is a right angle. So I'm actually going to skip down to letter D here that says name a right angle. So angle 2 is a way that we can say this. This is something that's new that we haven't done yet. If there's numbers inside where the angle measurement is, you can actually use that as another way to name the angle. If you want to go back to what you're used to, though, you can use the 3 letters B, C, D. So angle B, C, D. Either of those would have worked. Okay? And now I actually want to jump to letter C. Letter C. So letter C says name a straight angle, and we know a straight angle measures 180 degrees. So really what we're looking for here is a line. And there's really only one line in the picture. There's this bottom line here, okay? So that, all of these 3 angles added together, right, that entire angle is a 180 degrees. So how do we name that? We can, my vertex, right, is point C. So I'm going to name it as angle ACE, angle ACE. All right, now I'm going to do a little bit of kind of a thought process to help us figure out A and B, because those are a little bit more challenging. If I know that ACE is a 180 degrees and that BCD is 90 degrees, the two chunks that we have left over are this green chunk here and this orange chunk here. And what do those have to add up to is what we're going to try to figure out. So if I know that the straight angle is 180 degrees and this angle here is taking up 90, I'm going to take that away. And I'm going to get 90 degrees. So what I know is that the two angles that I have left over, the green chunks here and here, those need to add up to 90 degrees also. Okay? So now I know for sure that both of those green angles have to be less than 90, right? You can't have anything bigger than 90 adding to 90. So I have an acute angle here, angle DCE. Or you could have chosen this acute angle ACB. Both of those are acute. Let's move on to obtuse. So an obtuse angle, right? An obtuse angle is bigger than 90. It's between 90 and 180. So if I know that this angle here is 90, if I just add this chunk onto it and think about this entire angle right here, that's going to be obtuse. 90 plus something is obviously bigger than 90. So an obtuse angle would be angle BCE. And there are other examples of that in this picture, but let's just leave that one there. So this is kind of a challenging example, okay? It makes you think about what's going on in the picture, how the angles interact with each other. Let's look at the next example, and maybe that will be a little bit more clear. So this one, again, is the picture looks more complicated as I kind of stare at this. But what I like is that I see some numbers. Like I see the numbers 30 and 30 and 80 and 160, so I actually have like concrete examples on what I could do. Why don't you take a second to pause, and why don't you try one of these on your own? I know that you might not be ready for it, but give it a shot, and then we'll go through it again together. So hopefully you, let's start with letter A, and you named a right angle. So remember, a right angle is exactly 90 degrees. And that's going to be symbolized by the box. And we actually have two options here. I see a box right here, and I see another one over there. So there's two different answers that you could have. I think something that we need to be very particular about, though, is how we're naming these angles. So this, let's start with the one on the left here. This angle is what I've just drawn in red. So I'm going to name that as AFC. You want to kind of ignore everything around it and focus in just on that angle, okay? Let's look over here at the other one. That is my 90-degree angle there. So that angle was angle DBH. Either of those would have worked. All right, let's move on. Let's name an acute angle, okay? Just staring right at this picture, there I think are multiple options for an acute angle. Remember, acute angle is between 0 and 90, and I see 80, I see 30, and I see another 30. So let's just pick one. Let's just pick one of them. I'm going to pick the 30-degree angle down here. Okay, that is an acute angle. I know that the vertex of that angle is going to be A, and this is one of the sides, and this is the other side. Okay, so I'm going to name that as angle CAE. Remember, the vertex always has to go in the middle there. Again, you could have had other options. You could have done CFB or BEA, right? But we only needed one. All right, let's go down to an obtuse angle. An obtuse angle is greater than 90, so it's between 90 and 180, right? And I think in this case, there's only really one option that's labeled here. We could probably have found other options, but this is 160 degrees, so let's do that angle. So the angle is right here, and if I kind of follow the vertex and the rays that make that up, I get that angle, and let's name it as angle KAF. All right. Last but not least, let's do a straight angle. So if I'm trying to do a straight angle, that equals 180, but I think more importantly, I want you to think of a line. So you have to be very careful because there's, again, I think on this case, multiple answers that you could have, but there's just one line that kind of goes through this line right here. That line has 1, 2, 3, 4, 5 points. However, let's look at one more example, or one more thing that I want to go over, which is how angles are related in a triangle. Okay, so there's a couple of really important things that I want to go over before we talk about this point down here that I have written, and that is the word assume. This is going to be a word that I'm going to say a lot in class. Because you want to be very, very careful to not assume more than you know. So looking at the picture that we have here, the first question says, can we assume that angle O is a right angle? And if I look at angle O, that's this angle here. I think everyone's like first bet would be, yeah, you can assume that. However, is there anything in the picture, anything down here that says, yes, for sure this is a 90-degree angle? And that answer is no. So we can't assume that this is a right angle because there's no box here telling us that, right? Something needs to tell us more specifically that it's a right angle. All right, also, can we assume that angle C and angle N are congruent? Well, it's the same type of thing. Is there anything marked in the picture right now that says that they're congruent? Do they have tick marks like I had just drawn in? Do they have the same measurement like 30 and 30? And the answer again is no, right? Nothing is in the picture. I know absolutely nothing unless something is marked or given to me. But there is something that we can assume. And so moving out from here, we can assume that all three angles in a triangle add to 180 degrees. That will happen every single time. So we can actually use that to help us with what we were doing last class and set up some equations to find the value of x, right? So let's look at this example down here. It says determine the value of x. All I have to do is I have to look at this picture and be like, oh, how do I figure this out? I have no tick marks. I have no angle measurements to go off of, but I do have the fact that this is a triangle, and I have expressions for all three angles. And what do we know about all three angles in a triangle? We know that they add to 180. So I'm going to take that first expression up there, 15x plus 1. I'm going to add it to my next expression, plus 6x plus 5. And add it to this expression, plus 4x minus 1. All three of those angles added together must equal 180 degrees, and we can solve this equation now. Let's just combine like terms here. So we have 15x, 6x, and 4x. 6 plus 4 is 10, plus 15 that's 25x. And then a 1 plus 5 minus 1, those minus 1s will cancel, and I'll get plus 5. That's going to equal 180. And then we can just move forward and solve from here. So I'm going to subtract 5 from both sides and get that 25x equals 175, and divide by 25, and I think that is 7. So x equals 7, and we're done. So let's go practice naming and identifying angles and finding the three angles in a triangle. Have a good day.